Let's look at finding the value of an annuity. An annuity is an investment in which a person makes a sequence of periodic equal payments. Annuities always have an annual interest rate, which can be compounded on any desired number of intervals. Typically, annual interest rates are compounded annually, semi-annually, quarterly, or monthly. There are several steps that need to be taken in order to calculate an annuity. First, we must determine the value of the initial deposit. Set that equal to A1. Then, determine the value of N, which is the total number of deposits. Next, we have to calculate the value of R. We can do that by dividing the annual interest rate by the number of times per year that the interest is compounded, and then adding 1 to the result. Finally, we substitute the resulting values into the equation for the sum of the first n terms of a geometric sequence and simplify the result. This simplified value is the value of the annuity after n deposits. Assume that Gary wants to save money to buy a car, so he deposits $100 a month into an account that has 7.5% interest, which is compounded semi-annually. We want to find out how much Gary will have in the account after 3 years. Let's find all of the necessary values needed to find the annuity. Since Gary originally deposits $100 into the account, A1 equals 100. Recall that N is the number of deposits. Since there are 12 months in a year, and he deposits money for 3 years, N equals 12 times 3, or 36. Now find R. Compounding semi-annually means compounding twice a year. So R equals 1 plus 0.075 divided by 2. Simplifying gives 1.0375. We now have all the values we need to calculate the value of the annuity. Recall that the equation for the sum of the first n terms of a geometric sequence is Sn equals A1 times the quantity 1 minus r to the nth power all over 1 minus r. So let's substitute. We get S36 equals 100 times the quantity 1 minus 1.0375 to the 36th all over 1 minus 1.0375. We can use a calculator to evaluate this expression. So we get that the sum is approximately equal to 7,368.87. Therefore, the account will have $7,368.87 after Gary saves his money for 3 years.